Well, hello! I hope you guys are all doing great and you're ready to start thinking about trigonometry. Today I'm going to tell you a story, and it's a story that a wise person once told me. And I've told it many times since, and I don't think it's ever been told the same way. But it's called The Legend of Chief SohCahToa. All right, so here it goes. There once was a young fellow who was going to be named chief someday.
I'm gonna be a chief someday. What?
This young fellow was a hard worker and always focusing on his studies. He knew he needed to do that in order to be a chief. In time, he developed a temper.
I'm so mad.
And it seemed that these times that he had a little bit of a temper, it was when he was working on math problems. Now I know none of you can relate to that because I know that math does not give any of you frustration. But he would get frustrated when it came to math, and specifically right triangles.
No more white triangles.
Well, one day he had had enough. He was done with those right triangles.
Ow! It just hurts a little. I don't cry about it.
You know, he just let off all his steam and he kicked that boulder. And he hurt his foot. And he hurt it pretty bad. And he came back and his toe was all mangled and it was so sore.
He walked down to the stream where he found a place to soak his toe.
That feels better.
And in that moment, he grew up. He knew that he needed to be more focused. And he did. No more anger, no more outbursts. He was focused. He was once again dedicated to his studies. He even learned those right triangles.
The young man did everything he had been asked to do and more. And his leader was very proud. And from that moment on, he was known as Chief SohCahToa.
I am Chief SohCahToa.
You get it? Because he soaked his toe.
So that's the story of Chief SohCahToa. And you know what? It's a true story because you saw it. You saw it, right? You saw it happen. So anyway, it's a true story, and that is going to help you remember, believe it or not, that story will help you remember the trigonometric ratios. And I'm going to explain to you what I mean by that. Okay, so here is trigonometry. So in order to understand what SohCahToa means, you need to know three words, and they are opposite, adjacent, and hypotenuse. And I have abbreviated them here.
I'm doing it. I'm making a trap.
All right, so we are going to look
But I'm not done.
at angle A, and angle A here, that is the angle that I am going to call my reference angle, just for right now. Okay, and so from angle A, we look at angle A, and all the way on the other side of the triangle is the opposite side. So we call that side BC, we call that the opposite. Okay, the hypotenuse is always the hypotenuse. That's always the side opposite. the right angle and it's always the longest. Okay, so the hypotenuse, that stays. It doesn't change. Sunny, you're kind of in my way. Sunny, you are actually in my way. You're on my triangle. I cannot teach them while you're on my triangle. This is an issue. Okay, sorry for the goofed up chalk mess, but sorry. All right, so anyway, we've got the hypotenuse is always the hypotenuse, but right now, if we're talking about angle A as the reference angle, that makes this side BC the opposite, and then the other side that is next to the angle that is not the hypotenuse, that's called the adjacent side. Adjacent means next to, and I know that both of these are next to angle A, but it's the side that's next to it that is not the hypotenuse. Okay, so that's opposite, adjacent, and hypotenuse. Now we're going to look over here, okay? And again, sorry about the chalk mess, but if you look at this triangle, it's the same triangle, but now we are going to talk about angle B as our reference angle. So from angle B, if you look on the opposite side of the triangle, it's this side, it's AC, that is the opposite. Okay, the hypotenuse is still the hypotenuse. Okay, but then the adjacent is this BC because it is next to angle B, but it's not the hypotenuse. These are the trig functions that you see on your calculator. They look like they say sin, cos, and tan, but it's actually sine, S-I-N-E, cosine, C-O-S-I-N-E, and tangent. Okay, and sine is going to be equal to the opposite side over the hypotenuse, cosine equals the adjacent over the hypotenuse, and tangent equals opposite over adjacent. So this is where the legend of Chief SohCahToa comes into play. See how this says SohCahToa? Well, sine equals opposite over hypotenuse. That's the so. Cosine equals adjacent over hypotenuse. That's the ka. And tangent equals opposite over adjacent. That's the toa. I would recommend writing this on your paper right now so that you can use it as reference. All right, so let's put those trigonometric ratios to use in actual triangles. All right, so we're going to look at the sine of A. Okay, and if we're looking at the sine of A, that means A is the reference angle. And remember, we've got SohCahToa. All right, so for sine, it's opposite over hypotenuse. So from the angle, we're going to go opposite, so 12 over hypotenuse, which is 15. Okay, but when you can reduce, reduce. So 12 over 15, that reduces to 4/5. So 4/5, that is the sine of angle A. We're not using any trig buttons yet. We're just finding the ratio right now. Okay, the cosine of A is adjacent over hypotenuse, so adjacent would be 9 over the hypotenuse, which is 15. So it would be 9 over 15, which reduces to 3/5. So that is the cosine. And then tangent. Tangent would be opposite over adjacent. So from the A, the opposite is 12, and adjacent is 9. So we have 12 over 9, or 4/3. All right. So I would like you now to see if you can figure out the ratios for a reference angle, angle C over here. It's the same triangle, but now we're going to use angle C as your reference angle. Okay, so go ahead and pause your video right now and see if you can work these out. All right, so let's see how you did. Okay, so we've got the sine of C opposite over hypotenuse, or 9/15, which is 3/5. Okay, notice that the sine of one is the cosine of another angle. Cosine would be adjacent over hypotenuse, or 12/15, so 4/5. And then tangent would be opposite over adjacent, or 9/12, which is 3/4. How did you do? So here's where the real fun comes. So we want to find the length of BC. That was the length of BC. All right, and what we know is the measure of angle A is 42 degrees and AC is 7 inches. All right, and so we're going to use trig to figure this out. I know that sounds super fun. So what we do is we look and see what pieces are labeled, including the one we're trying to find. So we labeled BC with an X. So from the 42, which two pieces do we have? Remember, we have opposite, adjacent, and hypotenuse. So from that 42, which two pieces do we have? Yes, I heard it. Opposite and adjacent. And which trig function do you use for that? So look at that SohCahToa that you wrote down. Yes, that's correct. I heard that. Tangent. So what we have to do is we're going to write this out. The tangent of 42 is equal to opposite, and opposite the 42 is X, over adjacent, or 7. Okay, and I will show you how to put this into your calculator to solve this now. So what we can do is we can make this into a proportion. So we can put this over 1 and we can cross multiply. So we can go X is equal to 7 times the tangent of 42. Okay, and so all we have to do is plug it into our calculator. Okay, and so we just type that in. Okay, we're going to type in 7 times, and then we find the tangent button, which is right here, the tangent of 42. And then we hit equals. And it says 6.3028, yada, yada, yada. So X is approximately equal to 6.3. And I don't have any units, so that's good enough. Okay, but you have to be careful because if you type in, if you go the other way and you type in tangent 42 times 7, I'm going to do that right now. Tangent 42 times 7, we don't get 6.3. And if you look up here, it's because right here, we're finding the tangent of 42 times 7. We're not finding the tangent of 42 times 7. Okay, so if you go that way, you need to put the tangent of 42, close parentheses, times 7. And then we would get our 6.3. But I would just go the other direction just so you don't have to worry about it. Okay. So that's how we do that. We just use trig to find a side length. Yay. I just wanted to show you something. If you're using your phone for this, you'll need to turn it to the side. And then once you've turned it to the side, if you're finding like the tangent of 30, you don't type in the tangent of 30, you type in 30 and then tangent. Okay, so it's just backwards. You push the trig function afterwards. All right, so now we're going to look at another one. Okay, and we are going to find the length of segment EF. Okay, and if we're finding the segment of EF, we're going to put an X there. Okay, and so then we look at the two pieces now labeled. Okay, we've got the 4 and the X, and from the 50, what is the 4? Yep, it's opposite. And then the X is the hypotenuse. Good. Okay, so which trig function uses opposite and hypotenuse? We're going to go back over here. Which one uses opposite and hypotenuse? Good, it's sine. Okay, so we are going to say the sine of 50 is equal to, and it has to be opposite over hypotenuse. So we look at the opposite, which is 4, over the hypotenuse, which is X. And that's how we set that one up. Okay, and then we can make this into a proportion. Okay, and we end up doing the cross multiplying. So we're going to go X times the sine of 50
is equal to 4. Okay, and now we need to solve for x. So we're going to end up dividing by the sine of 50. Okay, and so then my 2 sine of 50's cancel out, so x is going to equal to 4 divided by the sine of 50. Okay, and we can do that in our calculator. Okay, so I am going to type into my calculator 4 divided by the sine of 50. And it says 5.22. So whatever it tells you to round to, I'm just going to round to the nearest tenth. So it's approximately 5.2. And it makes sense because the hypotenuse has to be bigger than the side. So x is approximately equal to 5.2. Good job, guys. All right, we're going to do one more together, and then I'm going to give you a couple to do on your own. Okay, so we're going to try this one. And for this one, I'd like us to find the length of segment xz. So I'm going to put an x here, whatever letter you want. This might be confusing because there's 2 x's, but you can put whatever letter you want, okay, just to show that that's the value that you are finding. Okay, so from this 31, what 2 pieces do we have? Good, adjacent and hypotenuse. Okay, x is adjacent to the 31 and 10 is the hypotenuse. Okay, so adjacent and hypotenuse. Which one is it? I heard it, cosine. So we're going to say that the cosine of 31 equals adjacent over hypotenuse. And since it says adjacent over hypotenuse, we have to go with adjacent over hypotenuse. So we have to go x over 10. Okay, and we can do the cross multiplying thing, but I'm going to show you a shortcut in a minute. So right here we're just going to cross multiply 1 times x is x. So x is equal to 10 times the cosine of 31. Okay, and then I'm just going to type that into my calculator. 10 times the cosine of 31. And it says 8.57167, yada, yada, yada. So this is approximately 8.57. Okay, or I guess I rounded to the nearest tenth the last time. But whatever the directions say, I had no directions here, so I'm just going with it. All right, so if you look at this, this makes sense too because this side has to be less than the hypotenuse. So this is one that is reasonable. All right, so I have all 3 problems here that we did, and I want you to look at where the x is on each of these, and then what we ended up doing. Okay, on 2 of these we ended up multiplying, and 1 of them we ended up dividing by the trig function. So I want you to take a minute and look. Okay, so look at where they are out. The problems are outlined with lovely little wavy lines. Look where the x is, and look what operation we ended up doing. Do you see it? Yes, that's right. Okay, so if you look at these 2 problems, the x was on the top in the numerator, and we ended up just multiplying. Okay? So if you don't want to write down the over 1 and then do cross multiply, just multiply. Just take the number times the trig function. Okay, and then on this one over here, the x was in the denominator. And yes, you guessed it, we ended up dividing. So if you think about it, if x is in the denominator, that's when you divide. So denominator divide, letter D. Okay, so that's just a little tip, just a little shortcut. If you don't want to do all this cross multiplying over here, all you have to do once you set it up, you don't have to do any more work. Just take the number divided by the trig function if the x is in the denominator. And if the x is on top in the numerator, All you have to do is just take the number times the trig function. Okay? And that's all you have to do. So you don't have to do as much work as we just did. I just wanted you to see why they work the way they do. All right? And now I'm going to give you a couple to do on your own. Yay! All right, now you're on your own, and I know you can do this. For number 1, you're going to find the length of BC. So BC, that's where you're going to put your X. And for number 2, you're going to find the length of EF. All right, go for it, guys. You got this. Pause your video and work this through. All right, how do you think you did? Let's see. All right, so the 2 pieces that you see here are opposite and hypotenuse, so we're going to use sine. So the sine of 48 is equal to 12 over x. Okay, x is in the denominator. Sorry about the dogs barking. It's not mine. All right, so we're going to take 12 divided by the sine of 48. You don't have to do the cross multiplying, you can just divide. Okay, and you get approximately 16.15. All right, now for this one, okay, we've got opposite and adjacent, so it's tangent. So the tangent of 36 is equal to x over 6. Remember, you have to go in that order, opposite over adjacent, x over 6. So since x is in the top, you can multiply 6 times tangent 36, and you get approximately 4.36. There you go, you got it, guys. Congratulations.
Chief SohCahToa says good luck.